Okay, anyway. Number 7 on the Illuminate study guide. It says, what are the zeros of the function below? What's another word for zeros? X-intercepts. So we have to be able to find the x-intercepts. Sorry, it's still loading. But we've not in this unit learned how to do it from standard form, which is what is being shown right now. So the only way we really can solve this one is by putting it into Desmos and seeing where it touches on the x-axis, because that's what, by definition, x-intercepts are. So that's what we're gonna do. 6x squared plus 12x minus 48. Okay. 6x squared plus 12x minus 48, I think, is what the thing was. Make sure you guys double check it tomorrow too when you type it in. And then you're looking at where it touches on the x-axis. Is your horizontal axis. So these are my x-intercepts, my zeros. The way that it wants you to put your answer, and I made it so that it's just like the test tomorrow. The way that it'll want you to put your answer on the test tomorrow is with just what x equals. Like here it says x equals blank and x equals blank. To get the full points, it would say -4 and 2. That's it. It wouldn't say it in coordinate form, although that's still technically right. It's just, it'll mark it wrong, but I'll have to go back and add the points. So if you could just type it in the right way, the way that it likes, it would save you that step, but that's how it wants it. Questions on that one? Questions on any others? So I'd say at least half of your tests can be solved with graphing. You just have to know what to look, how to do it. Right, number 9. This one. Okay. So we have to select different transformations based on the equation. And when it's saying like transformed, it means from the parent graph, unless it gives you another equation to look at. It means compared to our parent function, how has this been transformed? What is our parent function? X squared. So if you didn't know that, maybe commit that to memory, put it on a note card. That's our most basic quadratic that we can have. So think about when we did the lesson. Do you guys know what this format is in? Not standard form. It's not factor form either. Vertex form. When we did that lesson and we talked about how changing the A, how changing the H, how changing the K changes the graph, like you could go back and memorize all those facts. Or since you do have graphing technology, you can use what we did during that lesson and graph the parent graph and the transformed one on the same plane and then compare them. That's what I'm going to do. You would have to know to graph your parent function there. And then type in the equation of the other given equation, the one that is asking about how it transforms. And I've memorized it now because it's probably like my 4th time doing it today. So here's my parent, here's my transform. Tell me all the ways that it changed. Did it go up, down, left, right? Did it reflect? Did it stretch? Did it compress? Table 5, can you tell me one of the things that this graph did? It did go up 4. A good way to tell is by comparing the vertex. The vertex of our parent graph is 0, 0. This y changed from 0 to 4. It had to have gone up 4. Table 6, tell me another way it changed. It went, sorry, one more time? It is reflected. Because one is upward U, one is downward U, so there had to have been a reflection. Table 1, can you tell me another way it changed? Left 3. Table 2, are there any other changes? It's stretched, and how do you know it's stretched? Tell me visually, you can tell me the equation. So the negative actually is what makes it reflect. But you're right, it does have to do with the A not being 1, or a -1 for that matter. When A is greater than 1 or less than -1, it does cause a vertical stretch where it becomes more narrow than the original. So all of these 3 things happened. Those are all the transformations. The most I think you could have with 4 transformations. So we can talk about how in the equation, this tells you if it goes up or down. This tells you if it goes left or right. This tells you if it reflects, stretches, or compresses. If you don't want to memorize all that, just memorize what we did right now. Plotting the parent, plotting our given, comparing them. Questions on this one? Questions on any others? What about you think? Number 6. All right. So we have what's the completely factored expression below. So the given is in standard form. We've not yet learned how to go from standard to factored. You'll learn that next unit. Right now, all we know is how to go from factored to standard. And the way that we do that is by multiplying these out. So honestly, you have to multiply all your answer options to see which one matches. Or you could try graphing, but again, like, I don't think the one on the test will help you, if that makes sense. I recommend knowing how to multiply all of these out. So you could FOIL, you could double distribute, you could box method, Jaden, do you which one do you guys like better? Okay, up to you. It multiplies in the exact same order. So double distributing would be me taking the first term from one parentheses, multiplying it by both terms in the second. What's x times x? X times 9. And that's positive. Make sure you show that. And then distribute the 4. What's 4 times x? What's 4 times 9? 36. And even before combining like terms, I know this isn't going to be my answer because this has a positive 36, which is not a negative 36, right? So I know it's not going to be this one. I'm going to keep going. But that's the only way I think you would know how to solve the one that's on your test. So now do this one. X times x is what? X times 9 is. And then over here, we have a -4 that we're distributing. Make sure you multiply a -4. It's -4 times x. -4 times 9. And it's looking good so far, but then when you combine like terms, the 2 middle x terms, what's 9x plus -4x? And it's positive, which is not what is in our given, right? So it can't be this one that's on my screen either. So now try the next one. I can tell you, I'm not even gonna try it because I know -4 times -9 is a positive 36. Let's get that one. But when I do multiply this one out, x times x is, x times -9 is, inner terms, 4 times x is, and 4 times -9 is. And now when I combine like terms, what's -9x plus 4x? Now it would give me the exact same thing they was originally given to me. So that's what you'll have to do tomorrow. Tomorrow, it'll not be something that you can just graph and see if it gives you the same graph. Questions on this one? Questions on any other parts of the study guide? Maybe constructive response, Josina? Number 2. Okay, so this has a table of values and a given equation. To complete any table of values, all you have to do is take the given equation, and if they give you an input, you plug it in for the input. If they give you an output, you plug it in for the output. In this one, they're giving me all t. So all I have to do is replace t in my given. So like my first t is 0. I would, everywhere I see a t, plug in a 0. So does everyone see how, like, all I did was plug in where there's a t, the input? The rest you can put in your calculator. I mean, I wouldn't put the left side is just notation. It's just saying you plug 0 into function h. But the whole right side you can put in your calculator. I've done this a few times, so I know that this one is going to equal 24. And then the next time you plug it in, all you have to do is change what's in the parentheses. Always use parentheses anytime you plug stuff in. You don't want it to be 581, right? You want it to be 58 times 1. Or you want it to be 1 squared and then times the negative 16. I think when I do that one, just from memory, I think that one's 66, I don't remember. But that one's just, can I use a calculator? And can I remember to plug things in the right way? So good on that one? I won't do the rest of the rows, but if you have a specific question about one of them, let me know. Other questions? David? When Matthew is back. Any from the constructive response, any other parts of the study guide, any from the optional study guide? Tiana?
I thought this one read very hard to keep talking about it. There was number 8 on the,
Okay, so you said you got it right, but you're not sure how you got it?
yeah.
Okay, so let's look at number 8. That one is similar to your constructed response, except for that your constructed response will not have options. This one does. So at least with this one having options, if you have absolutely no clue what you're doing, you could at least type in all the options and then see which ones touch at those spots that they show. Okay, the ones that will be your answers will be the ones that have zeros at 1 and 7. And I'm actually going to write it over here because I can't really keep scrolling back and forth. But we have zeros at 1 and 7. And then what is it showing down here? What do we call that part of the graph? What's this called? Okay, it's giving me my zeros and my vertex. So if you have absolutely no clue what you're doing tomorrow, at least on the multiple choice part, you can type in all your answers and see which ones have these features. Or you can't really do that on the constructed response because the constructed response doesn't have options. But since it's giving me my zeros and my vertex, the forms that I'm probably going to be able to identify first will be factored form, because I can easily see my zeros from factored form. And then in what form can you easily see your vertex in? Vertex form. Okay, I wouldn't jump to standard form. I think that one would be the hardest with what we're given right now. But just know that if it was standard form, then you can see the y-intercept really good, but that's about it. So I have, how many options are in factored form? So these two are in factored form. I cannot pick more than one. And it might not even be any, like, it just says select all that can be represented by this. But if I pick one, I definitely can't pick the other. It can only be one factored form. So which factored form would have zeros at 1 and 7? Think about it, don't say it yet. Looking at these two, you should be able to tell me the zeros pretty easily. Which ones have zeros at 1 and 7? Tell me now. The first one is correct. So zeros, think of it like what would make a parentheses 0? If my zeros are 1 and 7, that means one of the parentheses will become 0 when I plug in a 1, like what's 1 minus 1? So that is a 0. And then if I plug in a 7, 7 minus 1 is 6, but then if I go to this one, 7 minus 7, does that one become 0? So that's why it works. This one is gonna be one of my answers. We saw that the zeros tend to be like opposite signs. Okay, so, yeah, you can't pick two factored forms, so now that I identified one is right, I can't pick this one. Now let's go to vertex form. Well, actually, since I have factored form already, let's do factor to standard, because that's pretty easy. I would more recommend that than going from vertex to standard form. So to go from factor to standard, you would multiply these out. Let's do foiling. So you would multiply your first, what's x times x? You multiply your outer, what's x times -7? Multiply your inner, -1 times x, what's that? And then multiply your last in each parentheses, -1 times -7 is what? When I combine like terms, my two middle terms was -7x plus -1x. And that best matches this standard form. Oops, hold on, I don't like that. Okay. Does it best match this standard form or this standard form? The first one, at least the first one on my screen. This one has the wrong sign on the inner term. So then it can't be two standard forms. My last three are in vertex form. We know that our vertex is this, because we could see it on our graph. Remember, vertex is HK. Where is the H in relation to this? In the parentheses with the X. So remember, I told you I would not provide you that formula. That is still true. You would need to memorize your vertex formula or be able to recognize it. H is always in parentheses with the X. And it always looks opposite of its actual value. So if I'm plugging in a +4, it's gonna look like x minus 4 in the equation, so it can't be this one. The k always matches though, like if it looks negative, then it is negative in the equation. So then which one has to be my answer? This one or that one? This one. And it can't be more than one vertex form, so the most you could pick is 3. You could pick less than 3 if you don't think any of them match. But that's the most you can pick for a problem like this. Is 3. Good on that? All right, any other questions? Times. tell you that I knew the answer even without graphing it. Because the form that it's in is standard form. In standard form, you can see the y-intercept super clearly. It's always the c and ax squared plus bx plus c. Or like your constant, your single number in the problem is always your y-intercept. So there was no single number here, that means it must have been 0. And that's why I did that. Also, kind of disappointed, you guys could have just graphed it. And then looked at where it touches your y-axis. So be better tomorrow on the real thing. It's not x-intercepts, it's y-intercepts. Usually there's only one for your quadratic. If any. Okay. So, next one, what is the vertex of the function x squared minus 5x? Definition of vertex, the turning point of your graph, and all of these will be U-shaped. I don't have a really easy way of seeing it when it's in standard form. So what I would do is I'd probably just graph that one, x squared minus 5x. And then see where the turning point of my graph is. Okay, so that's vertex. Questions on that? All right, so then here's the next one. Does that graph have a minimum or a maximum? X squared minus 5x. Does it have a minimum or a maximum? Receive, make sure tomorrow, even if you have no clue, even if you don't care about your grade, just pick one. It's one or the other. I can't tell you how many times people either leave that blank, or they say neither, or they say both. It cannot be both. It's one or the other. So minimum, and this is the same one from the last problem, would be your lowest point. Maximum would be your highest point. There is a way to tell without needing to graph it, but honestly, if you're in doubt or just want to be 100% sure, just graph it. Is it my lowest point or my highest point? On this one, it's a minimum. Questions on that? All right, this may or may not be our last one, so we'll see. Does this have a minimum or a maximum? Negative x squared minus 5x. We caught that. The only change from this one to the last one is that we made it negative, the number in front of the x squared, which we know reflects the graph. And then, of course, if you didn't know, you could always just type it in. See, is it my lowest point or my highest point, my vertex? And in this one, it is my highest point, so maximum. That's all we have time for, I think. Jaden, E, you can come pick a prize. But just know, like, you'll be asked about all these different features, just like last constructed response test practice was. So x-intercepts of this, but you can start packing up. I know it's almost time to go. Jaden, you can still pick a prize even if it changes. But x-intercepts will also be something you're asked about.
I'm going.
Good job. Good job.
No, it's not, Sienna. There you go. Go ahead.
Oh my